Alrighty, howdy folks. This is section 10.2, which is calculus with parametric curves. Oh, this is a very difficult section. Nah, I'm just kidding. You will see this is again a ridiculously simple section. Okay, check this out. Given a parametric curve x equals f of t, y equals g of t, a less than or equal to t less than or equal to b, can we find dy dx? Okay, can we find the derivative dy dx? Well, notice y is a function of t and x is a function of t. So how in the world are we supposed to find dy dx? And the answer is very simple. You say dy dt over dx dt. End of the story. Can you find dy dt? Of course you can, because y is equal to g of t, so y prime or dy dt should be g prime of t. Right? Similarly, dx dt should be f prime of t. That's it. As simple as that. Yeah. Oh, okay. This before I say proceed. There's something that you need to see. Another way of looking at the same thing is when we say dy dx, would you agree that's the same as ddx of the quantity y? Notice how I'm saying of the quantity y and all that. There's a good reason for that. Okay, so remember it this way and it'll help you actually find even the second derivative and others. And this concept is going to be very useful when you go into some partial derivatives and things like that. This is the same concept that we use. This concept is used even when changing from Cartesian to polar coordinates, doing calculus in those things as well. All right. So remember this strategy. Look at how I'm rephrasing everything. Dy dx is same as ddx of y. And on the right hand side, we will do the same thing. We'll call this as ddt of y over dx dt. All right. So because we said ddx of y, on purpose we are thinking of this as ddt of y, so that those two things match. Okay. All right. With that, let's pick a simple ridiculous example. X equals e to the y equals, can you find dy dx? Yeah, piece of cake. Uh, X equals e to the t. So can you figure out dx dt? Yep, e to the t. Y equals e to the negative t. Can you figure out dy dt? Yep, take the derivative with respect to t and you get negative 2e to the negative 2t. And what do we do with dy dx? Divide them. Ta-da, we're done. Is that all, man? Yep, that's all. Okay, with that, let's go to how to find d square y dx square. Here is where we can use what I just said. We had ddx of the quantity y, right? To be ddt of the quantity y over dx dt. So when we have d square y dx square, what is that? That is nothing but ddx of dy dx, right? So what has changed? Off. That off part is different now. Earlier, the off part was the quantity was y, but now the quantity is dy dx. So in our formula, if you make that simple change, hey, make it d dt of the quantity dy dx, we are done over dx dt. Right? Notice how we are making use of this form to figure out the second derivative. Cool? Next, let's solve a problem. X equals c to the t, same thing. How do we find d square y dx square? We already found dy dx to be negative 2e to the negative 3t, right? So we need that because notice this has d dt of dy dx. So d dt of that dy dx, which we found to be negative 2e to the negative 3t over dx dt. We already had dx dt to be e to the t. I'm just plugging in. That's it. Are we done with this section? You bet. So if I gave you some stupid problems like this, hey boys and girls, x equals square root of 1 plus t, y equals square root of 1 minus e to the t or 1 minus t, can you find dy dx? Piece of cake. Cool. That finishes 10.2, folks. 10.3 is coming up. Uh, wow, whopping 5 minutes.